Good morning, everyone. Welcome to the class on test of hypothesis, where we are going to discuss Z test one proportion problem. Already in the last class, we did Z test one mean problem. So when we were talking about Z test one mean problem, the calculation of standard error was different. And here, when we do problem related to proportion, the calculation of standard error will be different. Okay, so only thing what differs whenever you do calculation in test of hypothesis will be the only the calculation of standard error. Okay, everyone, I hope you'll remember. So, like when we are doing a Z test one mean problem, when we are doing Z test one mean problem, that time how we found the calculated Z value. So we found the calculated Z value with the formula x bar minus mu divided by sigma by root n. So we use this formula to find the value of calculated z value, where the formula of standard error, of the standard error, the formula of standard error was sigma by root n. Okay. Here also in one proportion problem, we'll do similarly the way we did one mean problem. Only difference will be the formula of standard error. Okay. So here the calculation of z value, what you will do, that will be that will be sample proportion. Okay, this is the sample proportion minus the hypothetic proportion what is given. Okay, divide by standard error, divided by the standard error. Okay, so earlier uh, in one mean problem, the formula of standard error was different. Here the formula of standard error that will be different. So the formula of standard error here, it would be ph naught into qh naught divided by n. Okay, this would be the formula of standard error, where here this is the sample, this is the sample proportion, this is the sample proportion, this is the sample proportion. Okay, this is the what you say, hypothesized proportion, or the population proportion. In the problem, there's a value of proportion will be given to us. So this is the population proportion. Okay, so this, I hope you understood. Okay, so what is qh naught? Qh naught will be nothing but 1 minus ph naught. Okay, so ph naught is the population proportion. Okay, so like if you read this problem, in this problem, the first problem, question number 6, if you read in this problem, it is given there's a ketchup manufacturer. They are in process of deciding whether to produce a new extra spicy brand. The company marketing research department used a national telephone survey of 6,000 households and found that extra spicy ketchup would be purchased by 335 of them. So here the sample proportion will be 335 by 6,000. So that will be your sample proportion. So 335 by 6,000, that will give you a sample proportion. Okay. So so here your n is 6,000. Your n here is 6,000. Okay, then a much more extensive study was made 2 years ago, shows that 5% household would have purchased the brand then. So ph naught, that would be 5%. Okay, so if ph naught is 5%, then qh naught would be 0.95. Okay, so if ph naught is 5%, then qh naught would be 95%. Okay, so this you have to do at 2% significance level should the company conclude that there's increased interest in the extra spicy flavor. So this is a right-handed one-tail test. This is right-handed one-tail test. I hope you understand this, because there's a word called increase is there. So that's why this is right-handed test. That you can understand, this right-handed one-tailed test. Can do that. and your level of significance would be 2%. So once you understood this values, once you have an idea about this value, so whenever you get the problem, what you'll do, you write null hypothesis. You write null hypothesis. So here in null hypothesis, you'll write that there is no there is no increased interest. There is no increased interest. There is no increase. There is no increased interest. There is no increased interest in the extra spicy flavor. Extra spicy. There's no increased interest in the extra spicy flavor. There's no increased interest in the extra spicy flavor and in the current time. So there's no increased interest in the extra spicy flavor, or there's no increased demand of the extra spicy flavor. So 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 here, and then you write h naught is equal to p value is equal to 0.05. So earlier, 2 year before, the demand for extra spicy flavor was 5%, and still it is 5%. So that is what you need to write in null hypothesis. So there's no increase interest in extra spicy flavor in the current time as compared to the 2 year before. And in alternative hypothesis, you will write in alternative hypothesis, you will write that there is an increased there's an increased in alternative hypothesis, you will write there's increased interest in in the there's a in alternative hypothesis, you will write there's an interest. So in alternative hypothesis, you will write that there's an increased interest in the extra spicy flavor. There's an increased interest in the extra spicy flavor. So where in alternative hypothesis, you'll write p, uh, p dash is greater than 5%. Okay, so I hope you understand. Whatever is given in the problem, you will write in the null hypothesis, and the problem will end with a question. So where they will expect you to either to do one tail test or either to do tail test. So in case if they're expecting you to do one tail test, then there's a word called increase or decrease. Or if they're expecting you to do two tail test, then they will uh, question you in the term of indifference. So you need to understand whenever you read the problem that it is either is it a one tail test or is it a two tail test. So that part you need to understand by yourself. So there's a catch up manufacturing companies there. So they are thinking that should they come up with new product with having extra spicy flavor. So they're planning should they come up with extra spicy flavor brand or not. So they will come up with that brand only when there's reasonable demand for that product in the market. So 2 year before, the demand was only 5% people like extra spicy flavor. So they want to know if there's an increase in demand, then probably they will manufacture they will the new product having the extra spicy flavor. In order to do that, should they come up with this or not? For that only we are doing a test of hypothesis. Okay, so when we are doing this problem, you know that this is one tail test. I believe everyone knows that this is a one tail test. Now I'll talk about the of calculation of what you say, mm, calculated or critical, anything, any term I can use, calculation of critical or calculated z value. So for that I need what is p dash, means sample proportion, that would be 335 by 6,000, because out of 6,000, 335 people responded in favor of that. So out of so, so 335 divided by 6,000. So what is 335 divided by 6000? So that is 0.05583. 0.05583. That is point zero. That is 0.055833. Okay, so you get this is a sample proportion. Okay, pH naught is already given to you 5%. So QH naught, that would be 0.95. Okay, 1 minus, so simple 1 minus pH naught will give you QH naught. So sample error or standard error, whatever you say, sample error or standard error. So that will be standard error. That will be sigma by root n. So here no sigma. This is pH naught into QH naught divided by n. Whenever data is given in proportion, there is no standard deviation there. So pH naught is 0.05. This is 0.95 divided by 6000. I can solve this. 0.95 into 0.05 divided by 6000. This is 0.05 into 0.95 divided by 6000. Square root of this. Square root of this. That I'll get is 0.00 uh, 2813. 0.002813. That is 0.002813. So that is the value of standard error, 0.002813. So the standard error, this is the value of the standard error. So you just do this calculation. You can do this calculation. One minute, let me confirm this. SQ2, find the square root of this. 0.05 into 0.95 divided by 6000. 0.002814. 0.002814. So once you get the value of standard error, okay, once you get the value standard error, now you can determine that should you accept or reject by two ways. So you can simply calculate that value. So your calculated Z value, that will be your sample proportion minus your population proportion divided by standard error, divide by the standard error. So this is equal to sample proportion was 0.0055833, 0.0055833 minus 0.05 minus 0.05 divided by standard error, 0.02813. So that will give you the calculated Z value. This is 0.05833 divided by 0.002813. So you can find this. So this is so 0.05833 divided by 0.02813. So you'll get 19.84. So you get 19.84. So 0.00583 divide by this. Sorry, 2.072. This would be 2.072. We'll get 2.072. So you'll get the calculated Z value is 2.072. So this is your calculated Z value. So you can easily understand this. So the formula what we need to use here is your sample proportion minus your population proportion divide by standard error, which is PH naught into QH naught divide by N. You can use this formula. With this formula, you will get the calculated Z value. Okay, everyone. So your calculated Z value is 2.072. So once you get this calculated Z value as 2.072, so this I'll compare with the threshold Z value. This I'll compare with the threshold Z value. So my threshold Z value. So this is one tail test, right? This is one tail test. This is right-handed one tail test. So this is right-handed one tail test. Okay, where your level of significance, your level of significance is 2%, right? Your level of significance is 2%, 0.02. So this is the rejection region. The acceptance region is 0.48. So what you do, you go to normal distribution table, see the value corresponding to 0.48, 0.48, that is 2.06. That is 2.06. So the calculated Z value is 2.06. The calculated Z value is 2.06. The calculated Z value is 2.06. Sorry, the threshold Z value is 2.06 and the calculated Z value is 2.0. You can see that you can see that you calculated Z value. You can see here your calculated Z value is 2.07473 and your threshold Z value is 2.06 and your threshold Z value is 2.06. So the calculated Z value, since the calculated Z value is more than, since your calculated Z value is more than the threshold Z value, since your calculated Z value is more than the threshold Z value, so since our calculated Z value is more than threshold Z value, so we do not accept the null hypothesis. So we do not accept the null hypothesis. Okay, you will only accept the hypothesis. You will only accept the null hypothesis only when the calculated value should be less than the threshold value. What that mean? This mean there is a increase in demand. This means there's increase in demand. There's increase in demand of extra spicy flavor. There's extra spicy flavor. Okay, in the mind of consumer, there's increase in demand for the extra spicy flavor. So if the company want to manufacture, so the company if the company want to manufacture, so if the company want to manufacture the extra spicy flavor, if the company want to manufacture the extra spicy flavor, they can do that. So if the company want to manufacture extra spicy flavor, they can pursue it. They can pursue that. That is what we can get from this problem. Okay, so that is what we can get from this problem. So very simple. You can either do like this, or once you're done with this, you can also solve the same problem in other way. You can also solve the same problem other way. You can draw a normal distribution curve. You can draw a normal distribution curve where you mean is equal to 0.05. Okay, and then you can find this x value, your acceptance value. So your sample proportion should lie between this. This value will be 0.05 plus 0.05 plus standard error is 2.06, right? For 2.06 into ph naught into qh naught by n. So this will give you the, sorry, this is not mean well different. You can use this as ph naught. You can use this as p1. Use this as symbol. This is what this any symbol I can use. Proportion symbol, something px or p acceptance symbol. So this will be equal to 0.05 plus 2.06. That is your z value, and this, and you can find this is equal to, so if your sample proportion lies in this, we will accept this. This is 2.06 into 0.05 into 0.95 by 6000. I can solve this. So 0.05 plus 2.06 into this. So this is 0.002813. You can find px value is equal to 0.05 plus 0.06 into 0.005796, 0.005796. So you can find the px value. Px value 0.05. This is this plus 0.05. This is 0.0557. 0.055796. So any sample value between 0.05 and 0.05 and 0.055796, you will accept it. Okay, I hope you're understanding. So any value, so if my sample proportion, is between, if my sample proportion is between 0.05 to 0.05 0.0555796, 0.55796, then 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 if my sample proportion is this, then the hypothesis is correct. Then hypothesis cannot be rejected. Then hypothesis cannot be rejected. And here, what is your sample proportion? Your sample proportion is how much? Proportion is how much? Your sample proportion is 0.05583. You can see your sample proportion is 0.05583. So if your sample proportion you would be in that range, you'll accept it. But your sample proportion is more than that range. Okay. The proportion is more than that range. So you'll end up in rejecting the null hypothesis. If you reject the null hypothesis, means you're accepting the alternative hypothesis What is that alternative hypothesis? Alternative hypothesis is saying that there's an increase in demand for the extra spicy flavor. That is what we need to do. Okay, everyone. Now see the next problem. See the next problem. Everyone read that problem. So if you read this problem, you'll realize that and there's a person called Steve Cutter. Okay, so that person is actually running a hardware store. So this person, Steve Cutter, is running a hardware store. Okay, so in with that he sells a product called Big Blade Lawn Mowers. So there's a person called Steve Cutter. He is running a hardware store where he is selling a product called Big Blade Lawn Mower. Okay, and this person is very interested to compare the reliability of the mover what he sell. So the whatever what all quality of movers this person he is selling, he is very interested to compare the quality of or the reliability of the movers what he is selling, that he want to compare with the reliability of movers which is being sold nationwide. Okay, and the parameter what this person is using to check the reliability is like how many percentage of movers require repair during first year of their ownership. So how many actually require repair during first year of ownership? So how many movers require repair during first year of ownership? On that basis, this person is actually checking the reliability of movers. So the movers what this person is selling in the market, the movers what is selling in the market, he's checking the reliability of these movers. So he's checking the reliability of movers with the movers which require repair during first year of ownership. So he's checking the like how much percentage of mover this Steve Cutter is having, how much percentage of that require repair during first year of ownership. That value is comparing with the with how many percentage of movers which is sold nationwide, how much percentage of them require repair during first year of ownership. Okay, everyone. So that this person is doing. So on that basis, he's checking the reliability of the movers, what he's selling in the market, to prove the kind of movers what he's doing, what he's selling in the market, how much they are up to the mark. So that he's trying to do. So in null hypothesis, I'll write that there is no difference. There is no difference. There's no difference. There is no difference in the reliability. There's no difference in the reliability of 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 Steve big blade movers. There's no difference between reliability of big blade movers. There's no difference in the reliability of Steve big blade movers with those sold nationwide, with those sold nationwide, with those which are sold nationwide. So where in null hypothesis you write H naught is equal to 0.15. So that is what is given. So it is given that Steve knows that 15% of all big blade movers require repair during first year of ownership. Okay. Okay, this is my null hypothesis. Okay, my alternative hypothesis. My alternative hypothesis. So my alternative hypothesis. When I am gonna write my alternative hypothesis, what I'll write. So that alternative hypothesis will depend on the question what is being asked in the question. If you see, is there any evidence that shows that the Steve Blake blade mover differ in reliability from those sold nationwide? So in alternative hypothesis, I'll write that there is a difference. There is a significant difference in alternative hypothesis. I'll write, you can understand this is a two-tailed test because there's no word increase, decrease, more than or more less than. So In alternative hypothesis, right, there's a significant difference. There's significant difference in the there's significant difference in the reliability. There's significant difference in the reliability of the significant difference of Steve big blade mover with the Steve big blade movers. There's significant difference in the reliability. There's a reliability of Steve big blade mover with 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 those sold nationwide. So in that I'll write in alternative hypothesis PS naught is not equal to 0.15. So in null hypothesis, I wrote my PH naught is equal to 0.15. In alternative hypothesis, I'll write PH naught is not equal to 0.15. So you need to know what is one tail test, what is two tail test. So because here we are working on the scenario that there is a significant difference. So that in order to prove is there a significant difference or not, we'll do the test. We'll do the test. So here the test what we are doing. So if I talk calculation of if I talk about the calculation of what calculation of calculated z value, so for that what I'll do, I'll I'll just simply compare the n here is what is your n and here is 120 and exactly 20 of them required mover repair in first year of ownership. So n is 120. So your p would be equal to 22 divided by 120. So 22 divided by 120 that is 0.1833. Okay, so your calculated z value. So you calculated z value is 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 sample proportion minus population proportion divided by QH naught into QH naught divided by H. So your sample proportion is 0.1833. Your population proportion 0.15. Okay, and then this divided by pH naught. pH naught is 0.15 into 0.85 divided by n. N is 120. So point point zero three three three. So 0.0333 divide by 0.15 into 0.85. This divided by 120. So your n is 120 divided by 120. So this is 0.032596, 0.032596, 0.032596. So the calculated Z value, so calculated Z value is what you got point or 22 by 120, right? 22 by 120, right? 22 by 120. 22 by 120 minus 0.15. This you are dividing by the standard error. This is a standard error. You'll get 1.22. You'll get 1.022. You'll get 1.022. So this is your calculated Z value. This you will compare with the threshold Z value. So this you will compare with your threshold Z value. This you will compare with the threshold Z value. So this is two-tailed test. So, so there will be two rejection region. There will be two rejection because this is two-tailed test. So there will be two rejection region. You have to do a 2% level of significance. So 2% alpha is 2%. This will be 0.01. This will be 0.01. So alpha will be 0.01, 0.01. This will be 0.49. So you check this 0.49. So where the 0.49 comes, where the 0.49 comes, 0.49, that is 2.33. So the threshold Z value is 2.33. Threshold Z value is 2.33, while the calculated Z value is 1.022. So you calculated Z value is 1.022, and you can see that. So you calculated Z value is 1.022, and your threshold Z value is 2 point. You can threshold Z value is 2.33. Since the calculated Z value is less than the threshold Z value, less than the threshold Z value. So so we so we do not reject the null hypothesis. So we do not reject the null hypothesis. So if we are not rejecting the null hypothesis, what this mean? This mean if we are not rejecting the null hypothesis, what this mean? This mean this mean this mean what? This mean there is no difference. It means there is no difference in the reliability of the Steve. There's no difference in reliability of Steve Cutter big blade mover, Steve Cutter big blade mover. If we are not rejecting the null hypothesis, means there's no difference in the reliability of Steve Cutter big blade mover with with respect to the with respect to the movers sold nationwide. So here, when we are not rejecting the null hypothesis, means other way we are accepting the null hypothesis, means we do not get sufficient evidence to reject the null hypothesis because our threshold z value is more than the calculated z value. It means we are accepting the null hypothesis. It means that the Steve Cutter should not need to worry that whatever the kind of movers he's selling in his store, their reliability is as par with the reliability of the movers which are sold nationwide. So that is what you can interpret from this. So in the last class we did one mean problem based on Z test. In today class we have done one proportion problem based on Z test. Always remember that the proportion problems are always Z test. So you should not confuse between Z or T test. So whenever you have mean problem, they can be T or they can be Z, but when we have proportion problem, they are always a Z test. And whenever we have one mean problem, then you know the formula of standard error, that is equal to square root of p h naught into q h naught by n. Okay, everyone, that part clear with yourself? Anyone, any doubt, any question? So this much from the today class. Anyone, any doubt, any question?